Hello everyone. In this video, I'll be explaining about different tests that we do for materials and how different errors may occur. So when we are choosing any materials for construction, it is very important that we understand its performance. Okay. So for choosing any materials, we look at the performance of the materials. Performance in the sense we look at its properties, performance properties like strength. We look at its hardness, we look at its toughness, okay, creep. So all these different properties we are comparing, and then we're choosing the right materials for our structure. Okay. So looking at this strength, we do the compressive strength test, tensile strength test, shear strength test. So this can be done using UTM, Universal Testing Machine. Okay. Next, we have a test for creep. We have for impact test, which is sharp impact test. Okay. And then we have hardness. So we can use Brinell hardness test. We can do to know its hardness. Then so sharp impact is for the toughness and Brinell hardness is for hardness test. Okay. So these are different instrument or equipment we use for testing the material. So it is important that we know the properties because the material has to take the load. Okay, so it should be able to resist different types of load. So it depends on what you're constructing, how many story buildings you're constructing, different types of loads. You are going to design or choose the materials accordingly. Okay. So when you're looking at this, we have for load in civil we use dead load, live load. Okay, dead load is the one like self weight of the building. Live load is the one like furnitures, humans. Then we have wind load, earthquake load. So all these different types of loads we are considering. Even the snow load for people like in cold countries. Okay, so because they have snow there, even rain. Okay, so all these forces are considered. Again, this loads we can say as static and dynamic. Static means the load that is constant with time, and dynamic is the load that changes with time. Okay. And very important parameters that we see in the materials is the Young's modulus of elasticity, which is the ratio of stress by strain. Stress means like force by area, so it's the strength, whether it's compressive strength, tensile strength, shear strength. So strength by the area. So how much stress is stress by area, force by area, how much force is applied to the surface area. So Young's model is stress by strain, and strain is change in length by original length. It's a ratio; it has no unit. Whereas strength has megapascal, or we say Newton per millimeter square, because it's force per unit area. So Young's modulus is very important parameter which we look at while we're choosing the materials. Okay. Then there is another Poisson's ratio. For example, if you see any material, we are going applying a force. So, for example, I'm trying to pull out. So it's going to extend. Okay, the length is going to increase. So as it's increasing, the lateral dimension will decrease. Okay, so there is a effect in the other direction. It's not only in x direction horizontally, but also in y direction. So this ratio of lateral strain by longitudinal strain is called as Poisson's ratio, which also we consider for our design calculation. Okay. Next, when we are doing all this strength test, so there can be some error. Okay, when you're looking at the properties and we are doing the laboratory test, so there can be the results may not be correct. So what are the reasons that the errors can occur? Okay, first, uh, the specimen. Okay, the test. For example, you are doing a test on the uh, maybe compressive strength. So you have to follow the standard. So it should be in 15 centimeter cube, okay, or the cylindrical shape. These two molds we use for our compressive strength test. So it should be in a standard and it should be properly mixed. So to get the target strength. So similarly, for any sharp impact test or you're doing, so the specimen should be correct standard specimen, okay, because the dimensions are always a standard when we do the test. Next can be when you're collecting the data. when you're analyzing the data. So maybe there is some calculation mistake for which your result has come. So you have to recalculate. And also the machine. So the list count, the functionality should be correct. When you're doing the test, the equipment that you're using should be in proper uh, condition. Okay, the function should, it should work properly. Then only you will not have uh, error in your test. So this is all about your test and errors for your materials. Thank you.